Hi, wishing everyone a very COVID afternoon, good morning, whenever you watch it. These are testing times, and I'm just trying a new mode to teach this very tough topic, but very important in the current era, known as advanced diagnostic aids in periodontics. Uh, the conventional diagnosis of all periodontal diseases is primarily aimed at using tools such as a mouth mirror, probe, and probably to a certain extent, uh, some microscopy here and there to identify the bacteria that are involved in causation or progression of periodontal disease. As we all know, periodontal disease is multifactorial in origin. The origin of periodontal disease is multifactorial. There is bacteria which are accumulating on the surface of the teeth, and these bacteria, once they accumulate on the surface of the teeth, the mucosa, the gums around, the gingiva around these teeth initiates an inflammatory reaction. So the disease, what we actually see in our patients, is primarily the response of the host to these bacteria that are present in the oral cavity. Now, the diagnosis of periodontal disease this primarily depends upon the diagnosis of periodontal disease. The diagnosis depends upon multiple factors, and these multiple factors primarily uh, are clinical, radiological, and also at times immunohistochemical, etc. So in this lecture, we'll try and see what are the various newer techniques of diagnosis of periodontal disease. That's why we call this chapter as advanced diagnostic aids. Okay. So now it starts with an advances in determining the gingival signs of gingival inflammation. We are assessing advances in damage to what's the amount of damage that's happened to the periodontal tissues. We'll also look at newer tools available to assess halitosis, newer considerations around implants, etc. Let's start with this. The most conventional or the most commonest clinical sign of periodontal disease is gingivitis, and we know now for sure, you all know now that there are various signs of gingival inflammation, which include change in color, contour, consistency, surface texture. But we have to understand that all these signs of gingival inflammation are always clinical, and they're clinical only we come to know about them once already the change has taken place. We as clinicians are at no point in a position to identify, or rather say predict, that okay, this site of the tooth or this gingiva around this particular tooth is going to get inflammation today, or it will be prone to developing inflammation tomorrow. So we are looking at what we call as signs of disease. The current signs of disease, what we call now, all of them are sequel to already the disease process that's taken place, and they are not predictive in nature. So as you see here in the clinical picture, you can see that there are signs of gingival inflammation, whereas when you see a radiograph, the radiograph only tells us what's happened before we shot that radiograph. It's a history of what we call as past disease activity. Okay, and it doesn't tell us how will the disease happen or progress tomorrow, or how will it respond to treatment. So we are looking at treatment aids or tools which will tell us exactly that okay, if this is the condition today, how it will be tomorrow. And that's what is very important from our perspective. So gingival bleeding, we all know now the most commonest way to assess inflammation is gingival bleeding. The presence of bleeding from the gingiva is a sure shot sign that this is a disease process. At times, you may not see clinical signs of inflammation, but there is bleeding on probing. So at times, you may have patients who probably would not show any supragingival deposits, but the minute you take a probe and put it into the gingival crevice, it will start bleeding. And what is the amount of force you need to put is 0.25 newtons or 25 pounds or 25 grams, not more than that. Now, when you are putting that kind of force, you will elicit gingival bleeding. Now, this gingival bleeding, what is going to get elicited, depends upon the kind of probe what you are using, the amount of force that you're applying, because you cannot per se control exactly the amount of force that you're putting onto the gingiva. So that's why you need a tool that will help us identify exact amount of force. That's why we'll start looking at what we call as pressure sensitive probes. We'll cover them as we proceed further. One of the very exciting tools that came into the market some years back, much older back, that's like 1990, was a tool known as a periotemp probe, the probe which would help us identify the temperature of gingival crevice. You know, as children, we all know now that before you actually fall sick or very feverish, okay, before you actually hit a temperature of 101, 102 degree Fahrenheit, calling fever, you will start feeling feverish. Now, what do you mean by feverish? So you moved away from 98.3 to somewhere in 98.9 or 99. So exactly in similar manner, we now have an instrument known as a periotemp probe, which you can place in the gingival crevice. So for example, if I have a if I have a second molar or a first molar, and if I take this probe and place it into the gingival crevice in that particular area, and if it starts showing me a temperature which is going on to the red zone, it means that this site, which is showing a higher temperature than the rest of the site, is prone or is already showing initial signs of inflammation. In all likelihood, when you put the probe, there may not be any gingival bleeding. So an increase in temperature of a particular site indicates inflammation. And this periotemp probe would help us in identifying, or what we call as, what would I say, would help us anticipate rather that this particular site will probably undergo inflammatory process in due course of time unless any intervention is carried out. So that was the periotemp probe that was designed, and it's probably used in certain universities. We do not have one of them. Okay, the next and the most common tool what we are going to use in periodontics, and which is going to be the benchmark for every other measurement of periodontal disease activity, is known as a periodontal probe. Okay, there are various forms of periodontal probes. These probes are, some are marked, some are unmarked. You have rounded and you have sharp-ended. But at the end of the day, the idea is very simple. You have a metal instrument of a certain diameter. The tip of that instrument particularly has to be rounded so that it doesn't cause any tissue trauma. And then you're going to have markings on that particular probe. And these markings on a probe can vary from 1 to 10 or 15, depending upon what probe and which generation of probe you're using. So these markings on this probe will help us identify the disease process and the past disease activity. It doesn't tell us the current disease activity, but it will only tell us what's happened in the past and not what's happening or what is going to happen tomorrow. But yes, but it is, as of yet, it's probably the most reliable tool to identify the periodontal disease process. Okay, so now by a general rule of thumb, please understand, this is a general rule of thumb and it is not a dictum. Okay, so what we say is that if the probe measures anywhere in the range of 0 to 3 millimeters, then that sulcus is a healthy sulcus. It may have inflammation, but it is healthy. It doesn't show any signs of bone loss. On the other hand, any measurement more than 4 millimeters or above is usually an indicator that some kind of periodontal disease process has set into place in this particular area. But however, again, probing depends upon various factors. That includes the amount of force that is put in, the direction of the force, and in all those other parameters. So what we came to know was that in order to standardize the measurement, for example, how I, with the 15, someone like me who with 15 or 20 years of experience in perio, or 18, 20 years in experience in perio, the way I probe and the way you as a beginner probe a periodontal pocket, or the way a postgraduate student would probe, would be entirely different because we have our experience. Now, the problem, what happens is, if you probe 3 millimeters, a PG comes and probes at 4, and I come and probe at 6 millimeters, it means that the diagnosis is changing. For me, it will be periodontitis. For a PG's measurement, it will be probably initial periodontitis, whereas for you, it will be healthy gingivitis. So the same patient, the same site, but 3 different measurements. So we do not have something to standardize the measurements, and for that very reason there are a lot of errors that go with our conventional probing measurements, and that's why we now have classification of periodontal probing devices. The first one, or what is the most commonly used, is the first generation probe, which is known as a clinical instrument, what you all have now in your kits, and it is known as a standard metal probe. The second generation probe was a bit more modification. What they did now was the probing force by a PG, you, or by me are going to be different. So what they did now was that they altered this probing force. So now what they did, it's very simple. They put a spring or a pressure gauge in that if when you insert this probe, unless and until the two marks on the probe match, or there is an electronic cutout, it says like it gives a beep, think that, okay, you're exceeding the force. So as long as you're within the 25 newtons of force, okay, to a 0.25 newtons of force or 25 grams of force, the measurement that you record is appropriate. If you exceed that force and it starts beeping across those lines, and then you take the measurement, then it means that you have crossed the force, and so the measurement what you got at that force is inappropriate. Okay, so it controlled the force, but it still did not control what we call as the angulation, but it was much better than what we have in the conventional kits right now. Then the need was always felt to have something called as a third generation probe, which is automated. For example, now, what's going to happen now? I measure 3 and I tell, okay, 3/6 mesial, 6 millimeters, 3/6 buccal, 4 millimeters, 3/6 distal, 2 millimeters, 3/6 lingual, 8 millimeters. Now I'm telling and someone else is noting it. Now, in busy practices, as your practice increases, as you start seeing more and more patients in your clinics, what's going to happen is this numbering is a very painful process. You end up spending that much more time on your patients, and which is not appropriate. Okay, so what the need was always felt is to have a probe which would have a specific force, obviously, because the force is the most important criteria when it comes to determining how deep you probe in. Second, it should read the measurements automatically. So you insert the probe and automatically it should come on your monitor. And that is what is required. So that's what is called as third generation or automated force probes. So let's see each of them one by one. So as you see on the picture, there's a Williams periodontal probe, or rather called as the University of Michigan probe with Williams markings. You have metal one, then you have the UNC, University of North Carolina 15 number probe, and then you have plastic probe, the same probes but plastic but with marking, so that it says if the probe goes in the green zone, it's healthy. If it starts bleeding and a little bit of red is visible, or in the first row zone of white, then it's gingivitis. If you go more deeper, then it's periodontitis. So all these modifications of conventional manual probes came in. Okay. On the other hand, the second generation of probing systems were again manual. They were both manual as well as electronic, but the manual ones are also known as a true pressure sensitive, TPS probe. What it did was, in the probe, just see if I have, in the probe design, what we had was, we had a probe with a head, and if you crossed that certain amount of force, as I insert this probe into a particular bucket, and if I'm crossing that force, then the probe would not give me a reading. So what happened was, I had to go back, reduce the force, and then probe again. So that's what it did. So that was also known as what we call as a true pressure sensitive. So what happened with this second generation probe was, the force got standardized, but the direction was not, and it was still manual. It was not an electronic device. Okay. On the other hand, the third generation probes were much better. Okay, what they did was, it was more of computed probes. So let's see, the most important or the most commonly used third generation probes are what we call as the Florida probe. The name itself is very, very famous. It's designed by the University of Florida. Okay, the Florida probe is electronic probe. So this probe has got an handpiece, as you see on the picture. There's a probing tip with a rounded end. And then this entire unit is connected to a transducer element, and then which is read into your computer. So it's like a probe tip. Then there's something called a handpiece. This handpiece is connected by a cable to a transducer, something like the modem what you have now. If you remember, something called a modem for landline broadband. So it's that modem is like a transducer, and that connects to the computer, where this chart is automatically there and all the readings are automatically coming up there. Now, the advantage of the Florida probe system was, the force was always controlled. You could not put more than, one could not generate more than 25 grams of force. It would just not give a reading. Second, now you will see that on an average, the most common measurement that's taken is something called as probable pocket depth. It means that it is the depth of the pocket from the gingival margin to the base of the pocket. So that depth what we measure is known as a probable pocket depth. Now the problem of measuring a probable pocket depth is that it changes. For example, today it is measuring 8 millimeters on day one when the patient has come to the clinic. Okay, you've done the scaling, you've done root planing, polishing, etc. You put the patient on some oral hygiene instructions and patient has gone back, and the patient comes back to you at 3 months or whatever. And then if you again go and probe that area, then you'd probably measure it as 6, which was 6, it probably now measure 3 or 4 or whatever is the value. Now, you cannot standardize whether this reduction in the pocket has happened due to the base coming up or due to the shrinkage of the gingival. So you needed a fixed point of reference. So that's why there is something what we call as a stent. So that's why you used something called as a stent, which always acted as a fixed point. So that's why the disc probe, what you see on the right side, is is much better than what you have seen on the left side of the screen. The disc probe rested on a tooth. So every time I go and insert in that particular area, it would exactly sit in the same area. If I'm not placed in the same area, then the computer would beep and tell me that I'm not in the right area. So what this electronic device did was it told me how to probe and replicate the same point of probing, and then told me whether there was a reduction in the pocket due to shrinkage of the tissue or due to bone growth or regeneration from bottom. So that was the advantage of these Florida or electronic probe. So the advantages being constant probing force with electronic measurement, automatic storage of data. I don't have to worry about it. The pressure was always controlled. So actually the pressure at the point of insertion of the probe was controlled. So patient was comfortable. The discomfort was the appliance looked pretty bulky, and so at times patients didn't like the very sight of the appliance. Okay, and obviously very importantly, it had to be used by a bit more technically sound guy as compared to a lot of us. Okay. The next electronic probe was what we call as the Foster-Miller probe, which was developed at, if I'm not wrong, at the University of Chicago by Jeff Cote et al. Okay. What this probe, the Florida probe, used the teeth surface as a point of reference, whereas what the Foster-Miller probe did was it identified the cement enamel junction. Now the problem with using occlusal surface of the teeth as a reference is they can wear off. Okay. Whereas now if you have the cement enamel junction, if there's a probe system which helps in identifying the cement enamel junction, then what happens is it's very simple. The cement enamel junction doesn't change at all. It's exactly the same point. So when I inserted this probe, I always got the same point of reference. Okay, so the data was very clear, and what I always measured was its clinical attachment level and not a probing pocket depth. So clinical attachment level is a more precise way to measure periodontal disease process and its response to treatment or progression of disease as compared to what we call as the cement enamel junction. One more probe was a Toronto automated probe. Now the Florida probe gave us pressure control. The Foster-Miller probe gave us what we call as the recording of the cement enamel junction, whereas there was still a problem, and that problem was angulation, and this angulation was controlled in the new probe known as the Toronto automated probing periodontal probe. Now what this probe did was it had an automatic correction of angulation. It's like a gyroscope. No, you know, if you see your phones, etc., there is something called if you open up your phones, it will always tell you check the gyroscope. You know, you have to stabilize your phone against the Earth's surface. So something called a gyroscope. So this probe incorporated a gyroscope. So if I tilted the probe a bit more, if I have to probe like this, and if in case I tilted, it automatically corrected the measurement. So if I was measuring 6 like this, and if I tilted by 30 degrees, it would still give me a 6 measurement and not a 6.5. Okay, so that's more highly precise way to measure the exact pocket depth. So that came with the Toronto automated probe. Apart from that, now the current generation probes what are being developed are known as the 4th generation probe. They're not in market, they're still under development, incorporating much more faster way to measure the same thing. Apart from that, there's a 5th generation probe. This probe is actually not a physical probe. Okay. Now, what this 5th generation probe is, it's actually an ultrasound device. Okay. You all know now what's an ultrasound device. What it does, it sends a wave. As the wave hits a particular tissue and it bounces back. The bounce back wave is then visualized on the monitor. It's the way abdominal CT, abdomen ultrasound or a knee ultrasound or anything is done to identify soft tissue changes. Now, the same technology was used in designing the 5th generation probe or ultrasound probe. It's exactly like, it's nothing but a probe handpiece containing which delivers sound waves. Now, as the sound waves go and hit a particular tissue and they bounce back, depending upon the kind of tissue, what they're hitting, they will bounce back. It's like using your tennis ball. You hit against a wall, it comes back to a certain length. You hit against a wood surface, it gives a different. If you hit a tennis ball on a sponge, it hits back at a lesser distance. So the way the rebound happens, now this rebound would tell me exactly what's the amount of probable pocket depth, and that's done on a computer program. So what this 5th generation probe is done is nothing but what we call as the ultrasound probe, and that's very, very important to understand. It's sound waves, they hit the tissue, come back, and then you see the value on your this one. And it's very specific because the waves hit cementum, they give a certain reading. The waves hit the bone, they give a certain reading. The waves hit the soft tissue, they give a certain, and these changes, these tissues give exactly the same reading, and that's the biggest advantage. And the second most important point of using an ultrasound probe, it's absolutely non-invasive. You're actually not poking the patient anywhere. You're just running the instrument on the surface, keeping it at the mouth of the crevice, and then taking down the finding. This is probably the best way to measure the kind of disease process or whatever, or the probing depths or pocket depths, etc., around your teeth. Okay, so that's how is the ultrasound probe that's being used. Okay, so these sets of the advances in probing devices are now telling us exactly how to measure the probing pocket depth and get the exact way to get the pocket depths. And then when the patient comes back for a follow-up, how the things are working consistently on these cases. The next thing what we move is, how do we assess halitosis? We all know that halitosis is a very, very bad complaint. It can put anyone off. The toughest problem of halitosis measurement was till now was that the most common way to assess halitosis was actually smelling the patient, also known as what we call as the organoleptic method. So you actually keep a certain distance from the patient, ask the patient to breathe out, and then how foul was the odor, you recorded that degree of halitosis. Please understand, halitosis is a very, very important sign of periodontitis. Patients with periodontitis, deep pockets, abscesses, etc. smell very bad, and these smells are coming from something what we call as a volatile sulfur compounds. Now, the easiest way to check how bad is the VSC or the volatile sulfur compound would be to do something called as gas chromatography, and that's why we now have a tool known as a halimeter. Okay, what this tool does, nothing. You have to blow into also known as a gas. This is known as a gas chromatography. So you ask the patient to blow into a clean syringe, and those gas in the syringe are then assessed on a machine, and that will tell us how much is the amount of sulfur, how much is the amount of nitrogen, how much is the amount of sulphide, and different gases. And on that basis, you can actually enumerate. Okay, patients with abscesses have this degree of sulfur compounds. Patients with pockets only have this much. Patients with gingivitis have this one. So it will help you diagnosing your patient's problem. Okay, so the advantage, obviously, you can measure the VSCs and the particular, for example, VSCs like indole, scatole, etc. tell us exactly what kind of a problem. If it's primarily an endodontic lesion, you probably see high amounts of indole and scatole. If there's a necrotic tissue or an abscess tissue, then you will see a lot amount of cadaverine. So what VSCs are there, you can exactly pinpoint the diagnosis right up there in front of the patient. Okay, the next tool which came more handy, gas chromatography required a lab test because you collect the gas and then put it on the meter, and it would take time. So now the next machine that came was halimeter, also known as commercially known as halimeter. Okay, what you do is you give a patient a straw and you ask the patient to put that straw into the machine and then blow, and then the machine then would give you a reading, a digital reading. Okay, now what is reading? It's measured in parts per billion. Okay, if the patient has halitosis, then the readings would be more than 100. Anything below 100 would be healthy. If anything is more than 100, would be a deceased kind of a readings, or patient has a very frank degree of halitosis. One more tool to measure halitosis was a diamond probe, known as diamond probe. It doesn't have any diamonds per se. Again, measuring the various degrees of volatile sulfur compounds. One more device. So let's pause here for a while. I'll just come back. Okay. Next, we move on to the devices that are used for measurement of tooth mobility. Now, we all know that probably as undergraduates, you all would be in some issue, especially when you're taking your case histories. Okay, you measure a tooth as a grade 2. A staff will come and say it's a grade 3, or a PG will tell it's grade 1. And can happen the other way around. It's because we do not have a very clear-cut way to measure, because you're using either two fingers or a probe and a finger, and then you're checking how much it's moving. Now this can lead to a lot of errors. Now to avoid this kind of error on how bad is mobile is a tooth, we now have a device known as what we call as a PERIOTEST device. Okay, now what's a PERIOTEST device? A PERIOTEST device, the PERIOTEST device is nothing but a tool which is used what it does is, it's like the way your tuning fork works. Okay, so what it does, you take a device, it will apply a percussion force to the tooth, and then depending upon how the tooth moves in and out of the socket, it gives you a reading from the +7 to -8. Okay, so if the tooth is very firm in the socket, it would give you a reading of -8, and if the tooth is grade 3 mobile, then it would be a +7. So anywhere in the range of 0 to 1 would be something like a grade 1. Something like more than that, like +2, +3, +4 would be a grade 2, and something that's more than 7 would be what we call 7 or more would be a very mobile tooth. That's like a grade 3 mobile. So it gives a very specific reading, and then based upon this reading, you can say whether the tooth should stay in the mouth or this tooth particular should be extracted out of the socket. One more tool to measure this tooth mobility is also known as resonance frequency analysis. Is primarily used around implants rather than on natural teeth. It is done for implant stability assessment and not for natural teeth. Okay. The next set of diagnostic tools are radiographic. We'll come and cover this radiographic tools exactly in the next class. Okay. Before that, I'll just close this topic down. I'll post it up, and then let's see how it comes. Okay. Thank you, everyone. Now just stop this recording.